Hey friends, Ben again. Uh, I'm making a quick video here because I had a question in class of why does this weird formula that we refer to as the quadratic formula actually work? You know, why would anybody reasonably expect that? And that tied in really well with what we had talked about with completing the square. But the completing the square that we did in class, we tried to stick to pretty nice examples. Okay. So what I'm intending to do here is to work out a not nice example. It's not horrifying, but it's not super nice. Okay. So I want to work out a not nice example and then shift gears and show you in general that you can complete the square without knowing what any of the coefficients actually are. And that will tell you the general answer. Okay. So that's where I'm aiming at this. Apologies if I get a little scattered. I've already done this video completely and then found out that my iPad was not showing any of the things I was writing. So take two. Okay. All right. So I need to share screen and I want to share desktop 1, which probably seems kind of weird. It probably displays all the untidy stuff I've got on my desktop, but now it should be showing up what I've got on my iPad. So I just made up a quadratic equation here real quick that's not, not terrible, but it's not great either. Okay. So with regard to this, we're going to solve it like we did the complete squares problem that we looked at in class. We're going to first get all of our x stuff on one side. And then because it's got a leading coefficient that's not 1, we can't jump straight into completing the square. I want to do this in a certain way because it will figure into what we do with parabolas later. Okay. So I am going to take that 2 and factor it out of the x squared minus 12x. Okay. Now you could go ahead and just divide it out, but like I say, I want to do this in a particular way because it just comes up at some later times. So now to complete this square, you're going to look here at the coefficient of x, and you're going to take it and divide by 2 in order to get minus 3. Remember the minus 3. But we take the minus 3 and we square it, and that is the number that we will need to add in order to make this piece here into a perfect square. Okay, so essentially right now it is an incomplete square, but when we add the 9, it'll become a complete square. Now over here on the right hand side, we have something that's often a little confusing. Remember here that I just added 9. It would be natural for you to think, okay, so Ben's going to add 9 over here. But the thing is, I didn't really add 9. I really added 2 times 9. So I have to add 2 times 9 so that I'm doing the same thing to both sides of the equation. So now this is 2 times x squared minus, well, sorry, I don't need to write the whole thing over again. So now this is 2 times a perfect square. And because we remembered that minus 3, we can just write that square. And the other part here, the negative 17 plus 18 will turn out to be 1. So now you can go ahead and divide and have x minus 3 squared equals 1/2. So when you take the square root, you have to say, I want the plus or minus square root on the right-hand side. And so you'll have plus or minus the square root of 1/2. which you might also write as plus or minus 1 over the square root of 2, or plus or minus the square root of 2 over 2. Okay. I don't really care which way you write it. Any of those is perfectly correct. But I'm going to work with this one here because it will fit with what we do in the more general case. So now I'm going to add 3 to both sides and have x equals 3 plus or minus square root of 2 over 2. Or if you want to put it into a single fraction, you'd say that's 6 halves plus or minus square root of 2 over 2, which is 6 plus or minus the square root of 2 all over 2. Okay. And if you were looking for numbers, I think, I don't have my calculator on me, but I think these turn out to be about 2.3 or 3.7. Okay, those should be the two numbers that you get out of that. Bear in mind with what we're doing, I'm not going to ask you to approximate these. You can just stop when you get to that portion there. Okay, but some people it makes them feel a little bit better to see decimal numbers on these. So if that is what works for you, go ahead and do it. All right, so now what we're going to do is to get the more general case. So ax squared plus bx plus c equals 0. We don't know what a and b and c are, although we can say a shouldn't be 0 because if it is, then we don't actually have a quadratic equation, right? So that's really the only piece of information we have. One of my favorite silly jokes is that algebra is the language we speak when we don't know what we're talking about. That is to say, we have to talk about stuff that we don't actually have values for. In this case, the a and the b and the c. So let's just do the kind of thing that I did on the previous one. We'll say ax squared plus bx equals minus c by subtracting. Then we'll say a times x squared plus b over a times x is equal to still the minus c. Now, it's probably convenient at this point. No, never mind. I was gonna do something here, but let's go ahead and follow along. This here may be a little bit perplexing to you. We need to take b over a and divide it by 2. So that means b over 2a. And then we're going to square it, which just means square all the little pieces. And we'll have b squared divided by 4a squared. I said squared there, but then my handwriting doesn't look like a square. So there, fixed it. All right. So what we need to add is that messy thing there. But now on the other side, we're going to have a times that messy thing. So a times b squared over 4a squared. Okay. Now, you might as well simplify where you can there, that you get one of the a's to be knocked out. And so you have this equal to minus c plus b squared over 4a, right? Now, to tidy that up a little bit more, I'm actually going to go ahead and say I want to take my minus c and multiply it by 4a on the top and bottom. All I'm doing is least common denominators. It's just it doesn't look like least common denominators because it's got all these letters. But that means I will have b squared minus 4 times a times c over 4a here. Okay, so that was just tidying up. And now on the left-hand side, I will have x plus b over 2a quantity squared. And you're probably worried about this a out front. But since I'm going to take this part, see if I can save myself some handwriting. Copy and paste. Come on, paste. And I'll work that right there. Okay. So since I'm going to get rid of that a, I'm going to just think about dividing by a here. I'll have an a squared there because I divide by it as well. Okay. So that means I have x plus b over 2a squared equals this mess over here. Okay. And now I'll do that square root theorem thing where you have x equals, x plus b over 2a equals plus or minus. Now I'm going to take a square root of this. The top part, I'm just going to leave alone under the square root. B squared minus 4ac. The bottom part, since 4 is a perfect square, I'll write 2. And since a squared is a perfect square, I'll write a, because I took the square root of them. Okay? All right, then putting them together, we'll just subtract the b over 2a. And since they have the same denominator, we'll have the classic formula that you might at some point have memorized. And hang on just a second here. I'm going to put a little red box around it. So it's easier to pick out where it is. Wow, except my little red box died in the middle. Damn it. Okay, maybe I'm not going to put a little red box around it. This is my last chance. Yay, there's a little red box. Okay, great. So that is the quadratic formula, and you can just use it directly. You do not have to memorize this. But I'm going to say to you that as a math teacher, I kind of sort of have this obligation to make sure that you sat through that at some point, because you ought to see the things that are done. Everybody always says, I don't want to learn to complete the square because it's not a formula I can memorize. You know, it's all this process stuff. But complete the square always solves every quadratic equation. If you're able to do it with the variables in mind, then it solves the quadratic equation in a formula. And then when you need to have it solved like by a calculator or a computer, the calculator or computer has like a method or a function built in that just does this. So that's the thing that's going on, is that you can do processes. The computer can do the process you tell it to. It can't do anything else really, right? So this is sort of preparation for being able to write a computer program that does something. So anyway, hope that's helpful. If it's not, don't tell me it's not helpful. All right, just humor me. All right, we'll see you all in class.